Okay, Assalamualaikum warahmatullahi taala wabarakatuh and good evening to all of group members and have a nice day to Sir Shahruddin. First of all, I would like to say thank you to Sir Shahruddin for giving us this opportunity on presenting on Laboratory 2 demonstration titled as Soft Drink Beverage Mixer System. So, first of all, I would like to introduce my name and my group member first. My name is Muhammad Fakrul Shahmi bin Jamal. Next, we have Nurul Syafiqah binti Farizal and we have Izul Uzai bin Zulkifli. Without any further delay, we continue to the introduction of the laboratory 2. So, what is it? It is the laboratory two is all about. So, in this task, the student need or require to do a system for the soft drink beverage mixer system. So, as you can see on the figure shown on the slide, the system start at the single tank. When the start button is pressed, the pump will let the osmosis water into the single tank until it reach at the level sensor 2. The heater will on and heat up the water until 100 degrees Celsius and then the solenoid valve 2 is open. After that, then the osmosis water will fill into the mixer tank. When the osmosis water is about 2%, the motor 1 will automatically on. After that, the osmosis water will keep on filling until the mixer tank reach up to 85%. Only the solenoid valve 2 is closed and solenoid valve 3 will open to let the dissolved sugar in and reach until 97% of water in the mixer tank. After the water in the mixer tank reach 97%, the solenoid valve 3 will automatically close and solenoid valve 4 will open to drain out the flavor concentrators to fill in the mixer tank until the level of the mixer tank reach 100%. Then the solenoid valve will be closed. So after that, the water in the mixer tank will keep on mix. The motor 1 will keep mixed by the motor 1 for the duration which is 10 minutes. After the duration 10 minutes, the solenoid valve will be open and the system will keep on repeat for the 12th cycle and will automatically stop and the buzzer will be turned on. The system will only resume back after the reset button is pressed. Last is where if the water in the single tank below to the level sensor 2 and the solenoid valve 2 is closed position, the sequence of the heating process will be continuous while the mixing operation will be on hold. So that's all the overall or general explanation on what is exactly the laboratory 2 is all about. So we proceed to the next presenter on the experimental setup.
I will explain about the experimental setup for this lab 2. Okay. For the experimental setup, in this experiment, there are two types of connection, which are digital and analog. So both have different way in setup the connection for the system. So before start connection, all the M which are M, 1M, 2M need to be connected with themselves. All the L which are L plus, 1L and 2L also need to be connected with themselves. Then we can start connecting all the input and output for the connection. Okay, firstly, for the digital connection, every input device, one of the wire need to be connected to the L plus, while another wire need to be connected to any input address that being used at the PLC. So, for the example, based on the table 1 of digital input output, the first input, which is the start button, we can see that the address number used is %10.0. Hence, when to do the connection, one of the wires at the start button need to be connected with the L plus, and other wires need to be connected at the %10.0 of the PLC. So, the same step also applied for every input connection. The difference is just the number of addresses used. Next, for the digital output. For every output device, one of the wire need to be connected to the 2M, while another wire need to be connected to any output address that being used at the PLC. So, for the example, based on the table of input and output device, the first output, which is the motor 2, we can see that the address number is used percent Q0.0. Hence, when to do the connection, one of the wires at the motor 2 need to be connected with the 2M, and other wires need to be connected at the percent Q0.0 of the PLC. The same step also apply for every output connection. The difference is just the number of addresses used. Another type of connection, which is analog connection. In analog, the address for the connection that can be used only have two, which are %IW64 and %IW67. Then, for the connection, we cannot directly connect L plus with analog input address because at L plus consists of 24 VDC, but at analog input, the voltage is only between 0 to 10 volt. Hence, it cannot be connected directly. Okay, so what we can do is add a resistor to voltage drop that 24 VDC and another variable resistor that can varies from 0 to 10 volt. Okay, for the example, for the temperature sensor, which is thermistor, the variable resistor is indicating the thermistor. If there is another analog input, just add another same connection and change the type of sensor. So in this case, another analog input is the ultrasonic sensor. For every analog input must be connected together with the analog output. Okay, that's all for the experimental setup from me for the explanation. Thank you.
Okay, for the in the programming of the system, we have divided the programming into three parts, which is, as we can see here from the left side, we have single tank, we have mixer tank, and we also have the all ingredient mixing. Okay, first we will talk about the single tank. Okay, in the single tank program in the network one is the network one is for the system on and off program. We use the set reset for the system on and off. Well, for the network 2 is for the when the water reach sensor level 1, the solenoid valve on and pump wheel off. That is for the network 2. And for the network 3 is the program for the water level, whereas when the first one, when the water is level is 30%, the level sensor 2 is on, and when the water level sensor is 90%, the level sensor 1 at the single tank will be turned on. The network 4 here is the division of the water level. Without this division, the animation of the water level on the single tank that use the bar function will not operated. Okay, at network 5. At network 5 is the another program for the level sensor. Okay, at network 6. Okay, at network 6. Okay, this is the program for the heater. Based on the question given, the water heater needed an analog output. Hence, the move function is needed for the analog input. As we can see here at network 7, the program for the analog input temperature sensor. it will transfer the input analog by using the move function here to the analog output. Okay, that's for the single tank. Okay, alright. Okay, next at the mixer tank at network 1. Okay, this is the analog program for the ultrasonic sensor. Ultrasonic sensor use the analog input, hence we need the norm X to normalize the value of the input. And this will be the scale X for the analog input to function well. Without this scale X, the value of the analog input could not be read in the PLC system. So we need this scale X to function. Okay, next at network 2. Okay, this one is the temperature level. The programming for the temperature when it reaches the 100%. We need this temperature level to also control the mixer tank, because after the temperature level in the single tank is 100%, automatically the solenoid valve 2 will be closed, and the mixing tank will be receive the water. Okay, we put it here because it have the connection with the mixing tank. Okay, the first one, when the water from the single tank is filling in the mixing tank. Okay, when it reach for the 2% in the mixing tank, okay, which is this one, it will give output to the ultrasonic sensor. Ultrasonic sensor will sense that the mixing tank is at 2%. But in this condition, the solenoid valve 2 will not be closed yet, because the question asks the solenoid valve 2 will only be closed when the water is 85%. Okay, so what we do, we also use the comparator function, which is this one. Okay, when the water level is 85%, automatically the solenoid valve 2 will be closed. Hence, the percentage of 85% water will be the reset for the function of the solenoid valve 2. Okay, next, when the solenoid valve 2 is closed, the solenoid valve 3 will be open to let the dissolved sugar to fill in. Okay, this one will also use the solenoid. We also use the comparator. When the mixing tank is 97%, the solenoid valve 3 will be closed. Okay, after that, after solenoid valve 3 is closed, okay, which this one, the program for the solenoid valve 3, we can see here that we also need a reset for the function of the solenoid valve 3 to function. It say here that the solenoid valve 3 will be only closed. It will be only reset when the mixing tank is 97%. Okay, next, when the mixing tank is 97%, the SV3 will close and the solenoid valve 4 will be open. Okay, we'll also use the comparator when the solenoid valve 4 is open. Here, the set for the solenoid valve 4 is the percentage of the mixing tank with 97%. This solenoid valve 4 will only be closed, which is will only be reset when the mixer tank is 100%. Okay, that is for the mixing tank operation. Okay, next we go to the when the all ingredient mixing. All ingredient mixing means that when the all of the operation for the 4 condition is fulfilled. When that condition occur at network 1, we place the timer, which means that after 10 minutes, the mixing tank is mixed all the water all together for 10 minutes. The SV solenoid valve 5 will be open after 10 minutes. And then this solenoid valve 5 will continue the system. The network 2 is just the program for the counter, because the system need to be repeat for 12 cycles. After 12 cycles, the buzzer will be on. That is for the program for the soft drink. Okay, next we will go to the HMI of the system. HMI system that is based on the program just now of our HMI. Okay, this is a program of HMI. When the start button is pressed, the operation will turn on. The pump, the solenoid valve 1 and M2 and M3 will be on, and the pump will be let in the water to the single tank, we can see that the water is filled in, and when it reaches the level sensor 2, it will do nothing except just sensor just send the water. Okay, we wait for the water to fill in. Okay, after it reach the level sensor to detect the water. Okay, then the water from the osmosis water will be keep on filling the single tank until it the level sensor 1. Okay, after it reach the level sensor 1, the pump and solenoid turn off and the heater will be turned on. And the temperature sensor will be also turned on. Okay, we can see that the heater right now is already turned on. Now we will control the temperature sensor at the syn table. Okay, when the temperature sensor reach until 100 degrees Celsius, so it means in high temperature. So automatically the water will be drained out and the solenoid valve will be open. So we will control the water using the ultrasonic sensor. So when the ultrasonic sensor level is 2% osmosis water, the motor 1 will be automatically turned on, but solenoid water will be also turned on to let the another water fill in until reach 85% level. Okay, after 85%, the solenoid water will automatically close to let the solenoid valve 3 open to let the dissolved sugar water in. Okay, then when the dissolved water sugar fill in until 97%, the solenoid valve 3 will be turned off. And the valve 4 will be turned on. Okay, right now we can see the solenoid valve 4 is already turned on while the solenoid valve 3 is turned off. Okay, right now the valve concentrate will fill in the mixer tank until it reach 100% level. After 100%, the solenoid valve 4 will turn off and this water will be mixing for 10 minutes. After 10 minutes, the solenoid valve 5 will be turned on. If you can see here, the bottle is now already being filled in. You can see the water bottle is now changing its color. It means that the process is complete for one cycle only. Okay, that's all for me for the software PLC program, the demonstration. Now I will pass the next presentation to Fakrul to continue with the conclusion.
Thank you to Nurul Shafika for the explanation in detail on the program demonstration. So I will proceed on the conclusion. In the nutshell, the student have partially complete the program, which is the soft drink beverage water system, by using the Siemens S7 1200 PLC. It is the partially complete because only the flowchart and timing diagram, input output device and analog device are complete. But the programming for the LED type in the PLC and the HMI system is partially complete because there are some problem that occur based on the simulation that we have done before. So the problem that have encountered in the system that we are encountered in the system, which is the first one, is the system cannot display for the water to automatically drain out from the single tank, because we can figure out how to do that. So we could only manage to display the water level in the single tank to completely disappear, to indicate that the water is draining out to the mixer tank. After that, the problem that we that have encountered in the system is the buzzer at the output of the system is cannot be functioned. Next is the single tank start to refill itself when the mixer tank water is at the level 85%, even though in our system, we did not set the condition to be like that. Then, there are some glitch in the bar function, whereas when the system tank is refilled to certain level, the bar level at the mixer tank will suddenly pop up for a second, then disappear back. This condition is vice versa when the mixer tank also in refill condition. So, next is the system can only just do once. It need manually to press the start button back to make the system kick on to continue the counting. Next, as for the recommendation to improve the system is that the buzzer is really important in the system to alert the user for a certain situation. In our system, we fail to do so. Hence, the recommendation is that to improve the program of this PLC is to a better one, to do a better one which with the correct programming for the buzzer. Next, our complete program cannot do the cycle more than once because we have faced problem with our counter. Hence, the recommendation is to improve the system so that it can be keep on running without manually to press the start button again and again. Hence, it can be said that the student can manage well to use the address for the digital input or digital output and analog input or analog output. Aside from that, the student also able to learn how to set up the system to let the HMI communicate with the PLC. Finally, by the end of the laboratory 2 assessment, the objective of the assessment is achieved. To conclude this laboratory 2 report, we want to thank you to the subject lecturer which is Sir Shahruddin Osman for his effort on giving the better explanation for the student in completing this assessment. I think that's all from us. Thank you for give the focus on our presentation on laboratory 2 demonstration. That's all from us. Thank you. Assalamualaikum warahmatullahi taala wabarakatuh.